Namaskar. Very warm welcome to all the viewers and learners in this live interaction of CIT NCERT. I am Renu Bhatt with you all and you are watching us live on PM E-Vidya channel, channel number 10, and apart from this channel, you are with us on our YouTube channels as well, that is NCERT official and NCERT PM E-Vidya class number 10. And dear viewers, as you can see, I am accompanied by our sign language interpreter. Let's meet her. You are Miss Nena. Nena, very warm welcome. And dear students, this session is for Science 10th Standard students, and the topic that we are going to discuss today in this session is electricity part. First, as we all know, it's a form of energy and it powers modern life. So, what else we are going to learn today in this specific session? Our expert will tell us more about it. So, without any further delay, let's quickly meet him. You are Mr. Bergin G. You are PGT Physics, Government Boys Higher Secondary School, Sayalgudi, Tamilnadu. Very warm welcome, sir.
Thank you, ma'am. Good evening to all.
Thank
Today's
you,
session,
sir. Thank you, sir. We'll definitely start this session, but let me share some certain information to all these students out there in case they have any query or they want to know more about electricity. Dear viewers, you can reach out to us through our various mediums. We want you to call us on our telephone number, that is 8800 440 559. Either you can drop a mail as well. Our email address is dth.class10th@cit.nic.in. And if you have joined us through our live streaming, then you have to go to the live chat box and then only you can drop your comment out there. Our expert will be more than happy to answer all your queries and doubts. So, let's quickly start this session, and Bergin sir, please explain about the topic and what content you have for our learners, sir. Please tell us.
Okay. Good evening to all. In this session, we are going to deal with the topic electricity of class 10 science. This topic consists of broadly classified into two parts. In the first part, it is circuit, simple circuit and Ohm's law, and second part, the resistance and various factors affecting resistance. So, in this session, we are going to just deal with the simple circuit and Ohm's law. Okay. From that topic, we can discuss some of the queries.
Okay, fine. So, sir, shall we start this session?
Okay.
So, I have a question, sir. How does electric charge differ from electric current, and in what ways are they related in a electric current circuit?
So, okay, it is nice question. The electric charge is everywhere. For example, if you have a balloon, the balloon has electric charge. If you have pen has electric charge, hair has electric charge, banyan has electric charge. So, everywhere charges are there. But how these charges are distributed? Look at this, the balloon, the total number of positive charge is equal to the total number of negative charge. In the hair also, there is positive charge and a negative charge, but both are equal. When you rub the balloon on the hair, hair has the tendency to lose the electron and the balloon has the tendency to gain the electron. So, after rubbing, if you analyze the charges present in balloon and hair, more number of negative charges are transferred from hair to balloon. So, we can find that balloon is electrically charged, that is, it is charged with the electrons, and the hair is positively charged, that means it loses its electron and it will become positive charged. So, in this way, the total number of charges in a system will be always equal, always same, no new charges are created. So, we can transfer the charge from one point to another point. The movement of charge per second is called current. We can call this as a current. That is the difference between charge and current. When charge is moving with particular time, then we can call that as a current. But how many charges are these electric charges are conserved, because if you count the total number of charges in this first case, balloon and air is equal to the total number of charge in the second case. After rubbing also, the same number of charges in that system, no new charge was created. So, we can say that electric charges are conserved. We cannot able to create new charges. We can transfer the charges from one place to another place. For example, if you
Okay.
consider a sphere, it has some charges. Billions of charges may be there. Let us consider, I will display some of the charges in that balloon. So each charge has some magnitude. We can call that as a value of the charge, that is 1.6 into 10 power minus 19 coulomb. Suppose this sphere has some charge of 4.8 microcoulomb. How many charges are there? We can just find out using some simple formula, because these charges are quantized. That means the charges may be 1, 2, 3, 100, 1000, billion, etc. It will not be 1000.5. So the fraction of charges will not be appeared anywhere. So if there are the unit charge is E, then n times of the unit charge is the total charge. From this, n can be found out, Q by E. Substituting the value, Q is 4.8 microcoulomb, that is 4.8 into 10 power minus, one charge has 1.6 into 10 power minus 19 coulomb. If I calculate this, I will get 3 into 10 power 13. So this sphere has charge 3 into 10 power 13 number of charges are there. So whenever we take something, it has charge. This charge is distributed like this. If you take a battery, it has charge. So if you make them charges to move, it is called current. So charge is quantized. Charge can be taken from one point to another point, etc. So this is the question. I hope I answered the question you asked.
Definitely, sir. So the flow of electric charge is current, right? So can you please explain how these charges, electric charges, flow from one point to another point, sir?
Yes. Now we learned that each object has charges, but if you make them to move from one point to another point, it will become current. To understand better, we can go from gravitational field. Now I just drop this ball from certain height, it will fall down. Before reaching the ground, it has some kinetic energy. Why? Because when a body is moving, it is moving with the velocity, therefore it has some kinetic energy. Just to say the kinetic energy is 4 joules. From where this kinetic energy come? The ball does not possess kinetic energy, but when it is in ground state, the potential energy is 0, because the potential energy is mgh, height is 0, therefore potential energy is 0. If I take the ball to certain height, I am doing some work. So the work done is stored as potential energy. So the potential energy is 4 joule. I just take a random number 4 joule. So if we place an object at a certain height, we are doing some work to move from particular point to particular point. So that work done is stored as potential energy. In the same case, the same thing is happening in electrical circuit also. Consider this point is negatively charged. If I bring some positive charge near to it, it will attract. In order to keep this positive charge inside that field, electric field, I have to do some work. If I do some work, then only I can keep that in that particular point, otherwise it will attract. So that work done is stored as potential energy. Here it is stored as potential energy. In the same case, in the same way, if two charges are same, then also it will repel with each other. If you bring the second charge near to the first charge, then it will repel. In order to avoid the repulsion, we have to do some work to fix that object at the particular point. In the same case, if both are positive also, similar thing happen. So whenever charges are there, there should be an electric field surrounded by the charges. In order to bring another charge to that particular point, we have to do some work. That work is stored as potential energy. So every point has some potential energy. Now look at here. If you consider a battery has one end if you consider a battery, in one end there is excess of electron, other end it is lack of electron, that we call as a positive terminal. When we connect this to a bulb with the help of a wire, it glows. What happens here? Because of the potential difference between these 2 points, the electron from the excess end will go to the electron with the lack of thing. In that time, there is a flow of charge. That flow of charge per second is called current. Now, you have to think one, you have to understand one thing. The electron is not glowing the electron is not glowing the bulb. Electron is used to glow the bulb, because here battery gives some energy. That energy is taken by the electron and it is supplied here. The bulb converts that energy into light energy and heat energy. With the loss of energy, the electron again go to the battery. It gets energy from there. Again it will come in a circuit. In this way only the circuit works. In a closed circuit, energy is taken from any source and it is supplied to different electrical appliances. For example, if you take, you just think of, we are taking bath. While we are taking bath, amount of water that we took is completely go out when you come out of the bathroom. So in that time, the water will take away the dirty from the body, and just it takes the dirty from the body. The same thing happening here. The number of electron coming out from here will reach at this point, at the end point. There is no new charges are generated, only particular charges only moving through the circuit. For example, if some 10 charges, some 10 electrons are coming from this negative end, the same 10 charge will be reaching the positive terminal. So the same number of charges only repeating, but the thing is it takes energy from the battery and supplied to the bulb. So whenever you thinking of the circuit, only energy is transferred. The electron is not giving anything. Electron taking the energy from the battery and it is supplied to the bulb. Let us consider one point with the 12 volt and another point with the 6 volt. If you connect with a wire, the charges from 12 volt pass through the charges from 6 volt. The same thing happening here. So when we connect a battery, the electrons flows through the circuit and the bulb glows. So in this way, the charge is converted into current with the help of a battery or anywhere where there is potential difference. So if we need current, there should be potential difference between any 2 points. If in the wire it is not possible to see all the charges move, only electron move. But if you look at the electrolysis process, there in liquid the positive charge is also moving, but in wire only electron is moving. So the current through the wire is because of the electron, and current through the liquid, that is in electrolysis process, both charges, positive charge and a negative charge, moves. So in this way the charge produce current in a circuit.
Okay. So you talked about potential energy, right? So could you please explain the difference between potential and potential energy, sir?
Yes. Potential means every point it has some potential. I already told that. Potential means the work done to bring a charge from one. Potential means if you bring a charge in a field, it experiences a force. Beyond that, we cannot be able to move. So the work done to move that at that particular point is called potential. So this point has potential. This positive end has some potential. Here is one potential. So each point has potential. So if you consider a battery, and in the battery consists of some charges, and if you have some bulb, If you connect it, positive end, it is VA, it is taken as VA, that is potential at the positive end is VA and potential at the negative end is VB. When you connect it with the battery, there is a potential difference. Because of the potential difference, the bulb glows. The energy is liberated from the battery and bulb glows. The question asked is, what is potential energy? Because energy is only shared through the circuit. Therefore, we have to know what is energy. Here the potential difference is potential between 2 points. In the battery, VA and VB be the 2 points. A and B are the 2 points. VA is the potential at A and VB is the potential at B. So difference in potential is VB minus VA. Work done is potential difference into charge. So if any source has some charge and it has potential difference, then that potential difference into charge will be the work done. This work done is stored as an energy that I already explained. Therefore, the potential energy is potential difference into charge. So, if you want to find out the potential energy in a circuit, that you have to multiply the charge with the potential difference across that source.
Okay. So, sir, let's take an example. If a student connects a battery, bulb and a switch in a circuit, but the bulb doesn't glow, what possible faults could explain this and how would you test each one, sir?
Okay. If a students connect a simple circuit with battery, switch and light bulb. So, what are the things we need to glow the bulb? As I already told, there is a potential difference, there is a charge, then my charge and potential will give the potential energy. If the battery has certain potential energy, the bulb will glow if the circuit is closed. So, we need a battery with charge and has potential difference and a closed circuit, and that are the things we need. Here, if the bulb is not glowing, that means this battery may be fault. There may be no charge inside the battery, or the two ends have no potential difference. So that may be possible. The student should check whether the battery is in good condition or not, whether it has charge or whether it has potential difference. Suppose if he checked with the multimeter, it will show 1.5 or 1 volt, then no issue. If it shows 0.001 volt, that means there is no charge, no potential difference on the battery. So in this way he can correct it. Or if battery is good, then only the connection matters. He has to check the connection and switch. If it is proper, then the bulb automatically glow. So for a simple circuit, we need a source of potential difference on bulb or on switch. Switch is needed because directly if you connect anything, if some wrong connection may be there, the bulb will be fused. So we have to put some switch in any circuit if you are studying something.
Okay, fine. Sir, could you please explain us Ohm's law and how is it used to control current, sir? And let me tell you, we have only 5 more minutes left for the session, sir.
Okay. Before that, I have to tell Ohm's law. After knowing the Ohm's law only, I have to explain that. Ohm's law means, that is one of the important session in this topic. Now look at this circuit. Here one battery is there, one resistance is there. With battery and one resistance in a closed circuit, a current is flowing. So that current is measured here. Now look at this 6 volt battery is connected with a 3 ohm resistance. We will get 2 ampere current. What is the meaning of that? The 6 volt potential difference gives some energy. That energy is passed through the 3 ohm resistance. The circuit will create 2 ampere current. Current is nothing but charge flowing per second. So 2 ampere current is there. Now I add one more battery. That means instead of 6 volt, I add 12 volt in series. So this is also similar circuit. instead of one battery, I double the value of the battery. That is, instead of 6 volt, I add 12 volt. I add 6 more to become 12 volt. Now look at the current, it is also doubled. When voltage gets doubled, current also doubled from 2 ampere to 4 ampere. I am using the same resistance. Now look at this, I add 2 more batteries, that now the batteries become 24 volt. I passed the current through the same resistance, now the current become 8 ampere. Now when I multiply the voltage 4 times of the initial value, the current is also become 4 times of the initial value, that is 2 into 4 equal to 8. So now I can say that the potential difference, that is voltage, given to the circuit is proportional to current. When I double, the current is also doubled. When I increase the voltage 4 times, the current is also increased by 4 times. So in general we can say that B is proportional to I. So V by I is a constant. Now look at this, 6 by 2, it is 3. Here it is 12 by 4, it is 3. Here it is 24 by 8. When I calculate V by I, the value is a constant. Here it is R. We can call that as a resistance. So V by I is equal to R, or V is proportional to I. This we can call as a Ohm's law. By knowing Ohm's law, we can find out the resistance or voltage.
Sir, in a brief, we would like to know, so as we are running very short of time, sir.
Okay. I will finish up to this. When there are 3 variables are V, I, R. If in some questions they may ask any one of these by giving the other 2. For example, here in this problem they are asking V by giving R and I. So by simply substituting that, we can find out the voltage or current or resistance in any circuit. That is the implication of Ohm's law.
Okay.
Ohm's law, one of the important thing that we have to know of the Ohm's law is it is measured at a constant temperature, because now look at this, if you increase the temperature, the resistance value also it changes. It depends upon the material, but it changes, it depends on temperature. So if you want to apply Ohm's law, the temperature should be constant.
Okay.
That's why whenever we are saying Ohm's law, it starts with at constant temperature, the potential difference across any source is directly proportional to the current. In that way only it is given. So temperature is one of the important factor that affects Ohm's law. We have to keep temperature as a constant.
Right, sir. Thank you so very much, sir. Bergin, sir, for being with us and for this insightful session. Thank you so very much.
Okay, thank you, ma'am. Thank you.
And I'm quite sure this session would be beneficial for all these students out there. Do let us know about your feedback. And thank you so very much, Naina. And before I wrap up this session, let me share a very important piece of information with you all. If you want to order 4th and 7th grades NCERT new textbooks, you can order it from Amazon, Flipkart and from NCERT's official website. And before I wrap up, let me share some sessions detail that we have for you lined up. And we will be back with our another live interaction at 3:30, and this that session would be for Urdu 10th standard students. हमारा उन्वान रहने वाला है ओ देश से आने वाले बता. At 4 p.m. we will be back with our another live interaction, that is our online training program. आज हम बात करने वाले हैं IoT device सुरक्षा पर. At 5 p.m. we will be back with our very special live interaction named Sahyog. हमारा टॉपिक रहेगा सेल्फ रेगुलेशन a crucial factor to sound mental health. At 5:30 we have our session for school head, that is NEPA. So be with us throughout the sessions with all your queries and doubts. Me, Renu Bhatt, is taking your leave, but you stay tuned to PME Vidya channels for more informative programs. Namaskar.